Good evening to one and all present here. I am Dr. K. Kannan, Assistant Professor, Department of Computer Science, Dr. SNS, Rajalakshmi College of Arts and Science, Coimbatore. Today, today we discuss about understanding the transaction management. Um, this is those are agenda is understanding transaction management is introduction to transaction, ACIT properties and transaction, and introduction to schedules and serial schedules and non-serial schedules, and conflict of serializability and view serializability, and precedence of graphs, and recoverable of schedules, and gasless of schedules. It is an introduction to transaction. The transaction is consists of the serious operations and executed of together, the ensuring the logical coherence of database. The data integrity is assurance is transaction or the vital for maintaining the data integrity and the preventing the partial updates and during the concurrent operations in scenarios. The next one is the consistency of maintenance, and by grouping the operations, transactions help ensure the database remains of consistent of state after the changes. And next one is what is the ACIT properties and transaction. The first one is atomicity, isolation, and durability, and already discussed. The atomicity is guarantee of all operations transaction are completed or none at all, and isolation is ensure the transaction is execute the independently and preventing the interference from the concurrent execution, and durability is guarantee permanent effects and committed transaction ensuring data survival of post crash or failures. And the next one is the schedules of definitions, and serial schedules execute the transaction the sequentially and ensuring to overlapping the operations, and thereby maintaining the consistency, and some of the serial schedules and key traits of including the simplicity of execution and order, and predictable of state transaction and easier error handling. The example for serial execution, the T1 and transaction 1 and transaction 2, the T1 completes before T2 start. It demonstrates a value of serial schedules. Non-serial schedules. It is a non-serial schedules in the, permit the overlapping of transaction, the enhancing the system performance through the concurrency and reshow the sharing. The benefits of non-sharing scheduling is improve the resource utilization and reduce the wait and wait times for transaction. They contribute significantly to system efficiency and throughput. The example of concurrent execution, the non-serial schedules, it is a transaction is the T1 and T2 may both read and write concurrently and optimizing the operations. And some conflict of serializability, it is defined as ensure the non-serial schedules are equivalent to a serial one view operation independence, and some of the testing method overview. It is employ serialization graphs and to identify the cycles of indicating the conflicts. Some illustrative example consider transaction T1 and T2. Their operation is demonstrate of conflicting access on shared elements of unique. Some view serializability, it is the guarantee of outcomes. The transaction is confirmed the some serial execution of sequence equivalently. Some comparison with the conflict of serializability. Unlike the serializability is view serializability of outcome rather than operation order independence. And characteristics of view serializability, it accommodates the diverse execution orders, ensuring the all operation and result the equivalent of serial transformation. Next one is some of the graph precedence of graphs. The introduction, it is a visualize of dependence in a schedule and facilitating of complex serializability of testing and analysis of effectively, and considering the graph, the create the precedence graph, identify the transaction and draw the edges of denoting the dependency between the conflict operations, and some of the interpreting of graph result, it is a conflict serializability, and it is cycle of instead of conflicts preventing and serious equivalence among the schedules. Some recoverable of schedules, like without the losing the committed transaction, ensuring the data consistency during failures, and cascading the rollback of prevention, avoid the cascading the rollback, and the strategy of including the some protocols and maintaining the dependency tracking efficiently, and the transaction efficiency, some impact the recoverable scheduling techniques enhance the overall transaction efficiency while safeguarding and against the integrity issues. Cascade schedules, those are definition and sequence of cascade schedules and example. And cascade is prevent of cascading rollback, ensuring the transaction does not read the uncommitted data. And some of the schedules is preventing of rollback, the propagation of across the different transaction during the failure. And example T1 and before the T2 reads, the isolation is the example is cascade is reducing strategies success. Some changes, challenge of transaction scheduling, and some deadlock, and starvation and performance overhead. Those are conclusion. The effective scheduling, and its impact of data integrity and system performance benefits, and effective scheduling, like enhance of transaction management by the preserving of data integrity and optimizing system performance. And some impact on the data integrity is proper transaction scheduling directly influence of data integrity through control the execution of order and conflict the resolution strategies. Some performance benefits, it is techniques of facilitate the better resource allocation, ultimately improving overall performance in the database system. Okay, thank you.